Welcome to Episode 13. Over the last episodes, we mapped the standards landscape. Now we go deep into the one standard that matters most for engineering ISO and SAE 21434. This is Part 1. It covers the front half of the life cycle, the management foundation, the concept phase, and product development through verification and validation. This is the work a supplier's engineering team actually does every day. Let's orient with the structure the handbook uses. 21434 is organized as 4 life cycle phases: a management foundation, then concept, then development, then post-development. But 2 things are not phases, they run vertically, through the entire life cycle. The first is continual cybersecurity activities, monitoring the world for new threats, and managing vulnerabilities. The second is TARA, the risk assessment method, which you can invoke at any point. Today, in Part 1, we cover management, concept, and development. Episode 14 will take the post-development phases. Like any serious engineering discipline, 21434 starts at the organizational level, not the technical one. The umbrella is the cybersecurity management system, the framework of policy, roles, and processes that governs how the company handles cyber risk. Clause 5 is governance. Executive management must commit, through a cybersecurity policy, and assign clear responsibilities and resources. It also covers culture, awareness, and sharing threat information across the industry, because no company sees every attack alone. Clauses 6 and 7 bring this down to earth planning and tailoring cybersecurity for each project, and managing the distributed work that flows between an OEM and its suppliers. The message for a junior engineer is this: security is a management decision before it is a technical one. Without that foundation, the technical work has no home. Now the concept phase, Clause 9, where security goals are born. It has 3 linked steps. First, the item definition, a precise description of the system you are securing, its boundary, its functions, its preliminary architecture, and its operating environment. Second, TARA, the threat analysis and risk assessment, which we will spend 2 whole episodes on later. Third, from the TARA results, you derive cybersecurity goals, and then write the cybersecurity concept that describes the controls to achieve them. The chain is simple: define what you protect, analyze the risk, set goals to reduce it, then specify the concept. And note, the item definition is the single prerequisite that feeds almost every later activity. Getting it right early pays off everywhere. Let's slow down on the item definition, because it is the foundation everything stands on. In the standards language, an item is a component, or a set of components, that performs a function at vehicle level, for example, a telematics unit or a braking system. A good item definition pins down 4 things. The boundary, exactly where the item ends and its environment begins, including its interfaces with other items. The functions, what the item is intended to do. The preliminary architecture, the components inside it and how they connect. And the operating environment, the conditions it runs in, plus your assumptions about access and attacks. Get these vague, and your whole risk assessment inherits that vagueness. Get them precise, and the TARA almost writes itself. TARA, Threat Analysis and Risk Assessment, is the engine of the whole standard. Here is its shape in one slide. We will spend 2 full episodes on it later. It runs 7 steps. Identify assets. Build threat scenarios against them. Rate the impact if each is compromised. Work out the attack paths an adversary could take. Rate the feasibility of those paths. Combine impact and feasibility into a single risk value. And finally, decide how to treat each risk. The one equation to remember is impact times feasibility equals risk. How bad would it be, multiplied by how easy it is to pull off? High risks drive your cybersecurity goals. Low risks may be accepted. And an important nuance, the standard does not prescribe the exact scales or method. Each organization defines its own as long as it is systematic. The last 2 steps of the concept phase turn risk into direction. Cybersecurity goals are the what to achieve. They are derived from the high-risk threat scenarios your TARA flagged, and they are often simply the inverse of a top threat. If the threat is spoofing of the break command message, the goal is to prevent that spoofing. The cybersecurity concept is the how to achieve it. It specifies the technical and operational controls that meet each goal, and it allocates requirements to the item as a whole or to specific components. To continue the example, the goal of preventing spoofing might become a concept of authenticating the message with a message authentication code, plus a freshness counter to stop replay. Goals tell you the destination. The concept is the route. Now we cross into product development, clause 10, where the concept becomes a real, secure product. This follows the familiar V model. On the way down, you refine the cybersecurity requirements through the levels of design, from system to software to hardware. Then comes implementation, building the controls in code and hardware, using secure coding practices to minimize the weaknesses an attacker could later exploit. And on the way back up, integration and verification at each level, you test whether what you actually built matches the requirements you specified. The discipline here is traceability. Every control should trace back to a requirement, every requirement back to a goal, and every goal back to a risk. That unbroken chain is what an assessor looks for. Two words that engineers constantly confuse. Let's separate them cleanly by the question each one asks. Verification asks, did we build it right? It checks that each cybersecurity requirement was correctly implemented through reviews, tests, and analyses at every level. It happens throughout development. Validation asks a bigger question, did we build the right thing? It confirms at vehicle level that the cybersecurity goals are actually met and that no unreasonable risk remains. This is clause 11. A neat way to remember it: verification is against the requirements, validation is against the goals. You can verify every requirement perfectly and still fail validation if the goals themselves were wrong. Both are needed before the product is released. Before we close part 1, one vertical activity deserves its own slide because it is where many newcomers underestimate the work: continual cybersecurity activities, clause 8. Security is not finished when the product ships. The world keeps producing new attacks, so 4 things run continuously in parallel with everything else. Monitoring, actively watching internal and external sources for new threats and weaknesses. Event evaluation, deciding whether a given event actually matters for your product. Vulnerability analysis, understanding the weakness in detail. And vulnerability management, tracking and treating each vulnerability based on a fresh risk assessment all the way until end of cybersecurity support. This vertical is exactly why a finished product still needs a living security team behind it. And it is the bridge into part 2. Let's recap with 5 lines. 1. Security starts at management. The CSMS policy, roles, resources, comes before any code. 2. The concept phase is define, assess, aim item definition, then Terra, then goals, then concept. 3. Development follows the V. Refine requirements, implement securely, verify at every level. 4. Verify versus validate. Did we build it right against the requirements versus did we build the right thing against the goals? 5. Some activities never stop. Monitoring and vulnerability management run for the entire life of the product. Here is the message to carry away. Good security is designed in from the very first concept. It is never bolted on at the end. In the next episode, we follow the product out of the factory into the post-development phases: production, operations, incident response, and end of life. Thanks for watching, and I'll see you in episode 14.